kids, welcome to today's maths class, and today we'll do symmetry. Our learning objectives are line symmetry, rotational symmetry, line symmetry and rotational symmetry together. Symmetry is an important geometrical concept which is used in every field of activity. The professionals, artists, architecture and many others make use of the concept of symmetry. The shapes which are evenly balanced and are perfect proportion are said to be symmetry. Next is line symmetry. A figure has line symmetry if there is a line about which the figure may be folded so that the two parts of the figure will coincide. This line is called the line of symmetry or axis of symmetry. If you see in the picture this line, if I fold this figure along this line, it will divide the given figure into two equal parts and one part will coincide the other part. अगर एक part को दूसरे के ऊपर करेंगे तो वो उसको totally overlap कर लेगा. So this line is called the line of symmetry or the axis of symmetry. Next is line symmetry and mirror reflection. Another way of knowing whether the line is line of symmetry for the given figure or not, it by using the mirror. Place a mirror along the dotted line and observe the image formed in the mirror. If the part figure of its image form is complete figure, then it is the line of symmetry of the figure. Therefore, line of symmetry is also known as the reflection symmetry or the mirror symmetry. Verify whether the dotted line in the given picture are the line of symmetry or not. So, if I place the mirror along this dotted line, I'll see the other half of that object. So that means this is the line of symmetry. Here you can see this is the line of symmetry. Clear? Next, know it. If a line divides the shape into two identical halves, we say that the shape is symmetrical and it has reflection symmetry. In reflection, there the left side change into right side in the orientation. Reflection में क्या हो जाएगा? Left right बन जाएगा and right left. The shape is same. Shape same रहेगा but the other way round. If you fold the whole shape along the mirror line, both the parts will fit exactly over each other. This mirror line is the line of axis of symmetry. This kind of symmetry is called the reflection symmetry. Symmetry related to mirror reflection. Next is lines of symmetry in some geometrical figures. A line segment is symmetrical about the perpendicular bisector. Line segment AB is symmetrical about the perpendicular bisector PQ. So this is the line of symmetry for this given line segment. The perpendicular bisector of the given line, that is the line of symmetry. An equilateral triangle, all three sides are equal, is symmetrical about the perpendicular bisector of each side. An equilateral triangle has three lines of symmetry. In triangle ABC, AD, BE and CF are the line of symmetry. So these are the line of symmetry in the equilateral triangle. An isosceles triangle is symmetrical about the perpendicular bisector of its base. In triangle ABC, AD is the line of symmetry. So in isosceles triangle, one line of symmetry, there AD is the line of symmetry. Clear? A rectangle is symmetrical about the perpendicular bisectors of the opposite side. The rectangle has two lines of symmetry. The rectangle ABCD, PQ and RS have the two lines of symmetry. Rectangle opposite sides are equal, so it has two lines of symmetry. A square is symmetrical about the perpendicular bisector of opposite sides and the diagonals. The square has four lines of symmetry. The square ABCD, PQ, RS, AC and BD are the four lines of symmetry. In square, it has four lines of symmetry. The rhombus is symmetrical about the diagonals. The rhombus has two lines of symmetry. AC and BD are the line of symmetry in the given rhombus ABCD. So these two diagonals, that is the line of symmetry in given rhombus. An isosceles trapezium is symmetrical about the perpendicular bisector of its parallel sides. So PQ is the line of symmetry in ABCD. So here PQ, this line is line of symmetry. In regular pentagon have 5 lines of symmetry. So here you can see in pentagon there are 5 lines of symmetry. A regular hexagon has 6 lines of symmetry. In regular hexagon, it has 6 lines of symmetry. Next, note. A regular polygon has as many lines of symmetry as it has the number of lines. A circle has infinite line of symmetry. In circle there are infinite line of symmetry. Next is symmetry in the letter of alphabets. Some letter of alphabets have the reflection symmetry related to mirror reflection about a vertical mirror only. So letter A, M, T, U, V, W and Y. It has vertical line of symmetry. This is the vertical line of symmetry. Clear? About the horizontal mirror only. So letter B, C, D, E and K. It has horizontal line of symmetry. About horizontal and vertical mirrors. So letter H, I, O and X. It has two line of symmetry, horizontal and vertical both. However, the symmetrical letter B and K are not available in the modern variety of design of letter. Some mathematicians do not approve the vertical line of symmetry in the L. The letter O is not complete circle. It is more of an oval. So it has only two line of symmetry while the circle has infinite line of symmetry. The following letters of the alphabet have no line of symmetry. All these letters have no line of symmetry. Next is symmetrical patterns. Fold a paper sheet into two halves. Punch a hole, unfold the sheet. We get two holes about the symmetrical fold. The fold is the line or the axis of symmetry. We can punch at different location on the folded paper and draw the corresponding line of symmetry. Like this, you can get the line of symmetry. Like this, fold the paper and punch the hole. When you open it, you'll get two holes. And this line, folded line, that is the line of symmetry. Next is exercise 13.1. State the number of line of symmetry for the following figure. An angle with the equal arm. So, an angle with the equal arm. It has one line of symmetry. That is the angle bisector of the given line. Clear? Practice all the questions of this exercise. Next is rotational symmetry. Rotation is the movement or turning of an object about the point through given number of degrees in a clockwise or anti-clockwise direction. The figure drawn below shows the rotation through the 90-degree clockwise about the point O. So, here it is showing 90-degree rotation. 90 degree rotate करेगा तो इस position पे आएगा. Anti-clockwise means like this and clockwise means like this. The direction in which the hand of the clock rotates, that is called clockwise. The opposite direction that of rotation is called anti-clockwise. For example, if you spin a wheel of the bicycle, it rotates. It can rotate both clockwise and anti-clockwise. What can you say about the rotation of the blade of the ceiling fan? Do they rotate clockwise or anti-clockwise, or do they rotate both ways? So, if you observe, typically a fan blade always rotate anti-clockwise. Know it. A figure is said to have the rotational symmetry if it fits onto itself more than once during a complete rotation. Rotational symmetry कब होगी? अगर कोई figure during rotation how many times it fit into original position, means जैसी उसकी original position थी उस position में कितनी बार आता है, that is known as the rotational symmetry during the complete rotation. Shapes and the size of the rotating object. When an object rotates, its shape and size do not change. In other words, the shape and size changes, it is not a rotation. Next, center of rotation. Center of rotation, the rotation turn an object about the fixed point, that is called the center of rotation. The center of rotation of the hand of the clock is the pivot. Clear? Means जिस point के around rotate करती है, that is known as center of rotation. Next is angle of rotation. The angle of turning during the rotation is called angle of rotation. A full turn means the rotation throughout 360 degree. A half turn means the rotation through 180 degree. A quarter turn means the rotation through 90 degree. Next is rotation of a paper windmill. At a quick glance, the paper windmill looks symmetrical, but there is no line of symmetry. No folding can get to conical. However, if we rotate it by 90 degree about a fixed point, the pin holding it 4 petals together, the windmill will look exactly the same as the very beginning. We say that windmill has the rotational symmetry like this. You can see if we rotate it, this is the position. Here point A, B, C and D. Clear? Now you will rotate it 90 degree. Clear? Anti-clockwise हो रहा है. So A will come here, B, C and D. Again you will rotate, A come here. So इस तरीके से 90 degree पे rotate करते हुए the position will change. So in a full turn, there are precisely 4 positions rotating through 90 degree each time, or on the rotation through the angles of 90 degree, 180 degree, 360 degree respectively, when the mill will look exactly the same. 4 times symmetry in the full turn is called the rotational symmetry of order of 4. So it has the rotational symmetry of order of 4. Next is order of rotational symmetry. Every object has a rotational symmetry of order 1 as it occupies same position after the rotation of 360 degree of full turn. So हर एक ऑब्जेक्ट में at least one order of rotational symmetry होती है. Clear? In other words, if it repeat the appearance of the starting position once in the full turn, it is called have the rotational symmetry of order 1. But here out the purpose to study the rotational symmetry of order more than 1. So a kite only looks the same once during the complete turn. So it has the rotational symmetry of order 1. So you can see the kite looked exactly same as the original position in complete rotation only once. So it has the order of rotational symmetry 1. Rotational symmetry of the order more than 1. Know it. The number of times the figure fits onto itself in one complete rotation is called the order of rotational symmetry. Next is rotational symmetry of regular polygons. Rotational symmetry of the square. Draw a square and join the midpoints. Opposite sides, 2 lines intersect at the point called the center of the square. Perform the quarter turn about the center of the square marked. We can see that the square look the same after each quarter turn. हर बार 90 डिग्री पे rotate करने पे it looks exactly same as its original position. The change can seen with the help of the position taken by the vertices A, B, C, D. Thus the square has 4 positions in the complete turn when it looked the same. So therefore in square the rotational symmetry is order 4 about the center. So 4 times it looked exactly like its original position. So it has rotational symmetry of order 4. Note. The rotation of the above figure is anti-clockwise. We may do it clockwise also. In the case of rectangle, it attained the position fitting onto itself when it looked the same after rotation throughout 180 degree and 360 degree. The full turn, there is only 2 positions when the rectangle looked exactly the same. So the rectangle has the rotational symmetry of order 2. Here you can see in diagram 180 degree after 360 degree. So it has the rotational symmetry of order 2. Next is rotational symmetry of the equilateral triangle. Draw the medians of the equilateral triangle. The intersecting point of the median is the center of equilateral triangle. An equilateral triangle fits exactly each time onto itself when rotate through 120 degree, 240 degree, 360 degree about the center. So it looked the same 3 times the full turn. So the equilateral triangle has the rotational symmetry of order 3. So after 120 degree, 240 degree and 360 degree, it will look same as its original position. Next is rotational symmetry of any 2-dimensional shape. Rotational symmetry of order 2. This is the initial position, then after quarter turn, this would be the position. Rotation through 90 degree. Again quarter turn, this would be the position. That is the rotation through 180 degree, the half turn. Observe each of the following letters which fit onto itself when rotate through 180 degree about O, and also when rotate through 360 degree in the full turn. Each letter looks the same 2 times. So, each letter given below have the rotational symmetry of order 2. So, all these letters have the rotational symmetry of order 2. Clear? Next is rotational symmetry of order 4. So, here you can see this is the original position, rotation through 90 degree, it will look like this. Again 90 degree karenge like this, again 90 degree and 360 degree. So, you can see 4 times it looks same as its original position. So, it have the rotational symmetry of order 4. Next is center, order, angle of rotation, symmetry of some shapes. For rotational symmetry, the measure of the angle of rotation in any case except the circle should divide 360 degree exactly. Shortcut: the figure is said to have the rotational symmetry if it looks exactly the same when rotated by less than full circle. The point about which the figure rotates, that is called the center of the rotation. The minimum angle through which it has to be rotated to look exactly the same, that is called the angle of rotation. Order of rotational symmetry, that is 360 upon x, where x is the angle of rotation for attaining a position looking like the original. So, here some shapes are given and their order of rotational symmetry. In square, order of rotational symmetry is 4, rectangle 2, rhombus 2, parallelogram 2, equilateral triangle 3, regular hexagon 6, circle and semicircle. Circle में हो जाएगा infinite and semicircle only 1. Clear? In other words, the daily life we have many shapes with rotational symmetry like wheels, electric fan, certain sliced fruit and some road signs. Next is line symmetry and rotational symmetry together. Some shapes have only line symmetry, some have only rotational symmetry, and some have both line symmetry and rotational symmetry. Some figures have equal number of line symmetry and order of rotational symmetry, but some have different. So, in rectangle you can see 2 line of symmetry and order of rotational symmetry, that is also 4. In square 4 line of symmetry and order of rotational symmetry, that is also 4. 6 side crystal, it has 3 line of symmetry but order of rotational symmetry, that is 6. An isosceles triangle has 1 line of symmetry with the rotational symmetry of order 1. Parallelogram has no line of symmetry but the rotational symmetry of order 2. Regular polygon have the same order of rotational symmetry as the number of sides or the number of lines of the symmetry they have. For example, the regular pentagon has the order of 5 rotational symmetry, 5 sides and the 5 lines of symmetry. Next is perfect symmetrical figure. The circle is the most perfect symmetrical figure. Every line through the center forms a line of symmetry and it has a rotational symmetry around the center of every angle. Thus, the circle has infinite number of symmetry or infinite order of rotational symmetry. However, the semicircle has only 1 line of symmetry and order of 1 rotational symmetry. Next is line symmetry and rotational symmetry in the capital letters. Some letters have only line symmetry like the letter E. Some have only rotational symmetry like the letter S. And some have both symmetrical like a letter H. So, we can compare the number of line of symmetry and order of rotational symmetry for the capital letter of English. So, in Z, number of line symmetry is 0 and rotational symmetry 2. In S, number of line symmetry is 0 and rotational symmetry 2. So, like this, some alphabets are given, their order of line symmetry and rotational symmetry are given here in this table. Clear? Next, know it. The figure with the 2 or more than 2 line of symmetry should have the rotational symmetry of order than 1. Next is exercise 13.2. Which of the following figures have the rotational symmetry of order more than 1? So, first one, it has order of rotational symmetry 2. Clear? So, like this we will find of order of rotational symmetry for the given figure. Clear? Next is summary. If a line divides a shape into two identical halves, we say that the shapes are symmetrical and it has reflection symmetry. A figure is said to have the rotational symmetry if it fits onto itself more than once during the complete rotation. The angle of turning during the rotation is called the angle of rotation. Order of symmetry, that is 360 upon x, where x is the angle of rotation. Some figures have both rotational symmetry and reflection symmetry. Next is multiple choice questions. Take the correct option. The number of letters in the word snail that have the line symmetry is S do not have any line of symmetry, N also do not have, A have line of symmetry and I have line of symmetry, L do not have line of symmetry. So, answer is C, 2. So, here we end the chapter. I hope you understand it well. Now to practice it.